Of all the mind-bending theories in modern physics, there is one that makes even the idea of a mirror universe or wormholes seem mundane. It is a concept that suggests our entire reality, the three-dimensional world we touch, the stars we see, and the very space we move through is actually an illusion. This theory, known as the holographic principle proposes that the 3D universe is just a projection of information stored on a two-dimensional surface at the very edge of the cosmos. Furthermore, it leads to a startling possibility that our universe might not just resemble a black hole, but that we are literally living inside one. This isn't just a philosophical daydream. It is a mathematical necessity born from the attempt to solve the greatest paradox in the history of science. To understand how we could be living in a hologram, we have to go back to the heart of a black hole. In the 1970s, Stephen Hawking and Jacob Bekenstein discovered something strange about black hole entropy. Usually, the amount of information you can store in an object, like a hard drive or a book, depends on its volume. But for a black hole, the information capacity depends only on its surface area, specifically, the area of its event horizon. This was a massive clue. It suggested that all the stuff that falls into a black hole, every atom, every photon, every bit of data, isn't lost in the 3D volume of the hole. Instead, it is smeared out and stored as a flat 2D image on the event horizon itself. If the information of everything inside a black hole can be represented on its surface, then the 3D interior is effectively a projection of that 2D shell. In the 1990s, physicists Leonard Susskind and Gerard 't Hooft realized this logic shouldn't just apply to black holes. It should apply to the entire universe. If you were to draw a giant boundary around the observable universe, all the information within that space could be mathematically mapped onto that boundary. This means that you, your house, and the entire Milky Way could be the 3D projection of data sitting on a flat, distant horizon. This is the essence of the holographic principle. Much like the 2D hologram on a credit card creates a 3D image when you tilt it, our 3D reality could be a holographic projection of 2D quantum bits. This solves a massive problem in the search for a grand unified theory. It allows physicists to describe the complex, gravity-filled world of general relativity using the simpler language of quantum field theory on a flat surface. It's a mathematical bridge that suggests gravity itself is not a fundamental force, but an emergent property of holographic information. But how does this lead to the idea that we are inside a black hole? The answer lies in the Schwarzschild radius ***. Every object with mass has a specific radius to which it must be compressed to become a black hole. If you calculate the mass of all the matter in the observable universe, you find something shocking. The Schwarzschild radius of the universe is almost exactly the same as the size of the observable universe itself. In other words, the density of our universe is the exact density required to be a black hole. If we are living inside a black hole, it would explain why the universe appears to be expanding. From our perspective, space is stretching. But from the perspective of an observer outside our black hole, that expansion could simply be the result of the black hole swallowing more matter and energy from its own parent universe. As the black hole grows, the space inside it expands. This creates a cosmic connection that links universes together in an infinite chain, like a set of Russian nesting dolls. Our Big Bang might have been the moment a star in a higher dimensional universe collapsed to form our black hole. This theory also offers a radical explanation for *** dark energy ***. As we discussed in Is Dark Energy a Fifth Force? The universe is expanding at an accelerating rate. If we are inside a black hole, this acceleration might be the result of the tidal forces of the parent universe pulling on the edges of our reality. It would mean that the nothingness of space is actually a dynamic environment shaped by the physics of a realm we can never see. We are the inhabitants of a gravitational pocket, living in the shadow of a much larger reality. The holographic principle also changes our understanding of the real scale of information. If reality is a hologram, then there is a limit to how much detail the universe can have. This is known as the Bekenstein-bound ***. Just as a digital photo is made of pixels, space and time themselves might be pixelated at the *** Planck length ***. If you were to zoom in deep enough on the fabric of space-time, you wouldn't find smooth curves. You would find the bits of the hologram. Experiments like the *** Fermilab holometer *** have attempted to detect this holographic noise, the jitter of reality itself, though so far the results remain inconclusive. If we are living in a hologram, it raises profound questions about free will and time. In a hologram, the past, present, and future are all encoded on the 2D boundaries simultaneously. The flow of time that we experience might just be our consciousness reading the data in a specific sequence. It aligns with the mirror universe theory's suggestion that the Big Bang was a symmetry point. In the holographic view, the Big Bang isn't a beginning, but the starting line of the data. Every second of your life is already written on the cosmic horizon. You are just the 3D manifestation of that pre-existing information. This perspective also touches on the Voyager Golden Record. We sent a 2D disk into space to represent our 3D world. In a poetic sense, we were mimicking the architecture of the universe itself. We were trying to encode the essence of humanity into a flat format, just as the universe encodes the essence of a star onto the surface of a black hole. If an alien civilization understands the holographic principle, they might see the golden record as a profound philosophical statement, a recognition of the true nature of reality. The dust-to-life journey also takes on a new meaning. If we are holographic, then our atoms are not solid things. They are just the 3D projections of quantum-entangled bits on a distant boundary. When we look at the rings of Saturn or the blue sunsets of Mars, we are looking at the beautiful, complex interference patterns of a cosmic light show. We are not stardust in the sense of physical rocks. We are stardust in the sense of mathematical information that has come alive. But if we are inside a black hole, what happens at the end? As we saw in How the Sun Will Destroy the Solar System, our local neighborhood has a finite lifespan. But a black hole has a much longer life. However, even black holes eventually die through ***, Hawking radiation ***. They slowly evaporate, leaking their mass back into the parent universe. If our universe is a black hole, then in the unimaginably distant future, it will evaporate. All the information that makes up our reality, every memory, every star, every bit of the golden record, will be leaked back out into the higher dimensional universe as a stream of radiation. We are a temporary thought in the mind of a larger cosmos. The holographic principle is currently being tested by some of the most advanced, deepest images of the universe. By looking at the ***, cosmic microwave background ***, the afterglow of the Big Bang, Physicists are searching for statistical patterns that would only exist if the early universe was a 2D holographic phase. Some researchers at the University of Southampton have claimed to find holographic signatures in the CMB data, suggesting that the early universe was flat and only became 3D as it cooled and expanded. If this is confirmed, it would be the ultimate eureka moment, proving that the world we see is an emergent illusion. The idea of living in a hologram or a black hole can feel isolating, much like the boat's void we will soon explore. It makes the world feel thin or fake, but there is also an incredible sense of cosmic connection in this theory. If the holographic principle is true, it means that every part of the universe is connected to every other part through the 2D boundary. In a hologram, every piece contains the information of the whole. This might explain the spooky action at a distance in quantum entanglement particles are connected because, on the 2D boundary, they are actually the same bit of information. We are not separate beings. We are all part of the same unified data set. As we move into 2026, the study of black hole information is the hottest topic in theoretical physics. We are building quantum simulators to try and replicate the conditions of a holographic boundary. We are learning how to program reality. If we can master the math of the hologram, we might eventually find a way to edit the projection. It sounds like science fiction, but it is the logical conclusion of a theory that says space and time are just software running on a cosmic hardware. The scariest planet or the most beautiful nebula are wonders of the 3D projection. But the holographic principle is the wonder of the projector itself. It tells us that we have been looking at the world upside down. We thought the 3D world was real and the 2D information was a description. It turns out the 2D information is real and the 3D world is the description. It is the ultimate mind-bending revelation, a shift in perspective that rivals the discovery that the Earth goes around the Sun. In conclusion, we might be living inside a black hole, and we are almost certainly living inside a hologram. Our reality is a beautiful, shimmering projection of information stored at the edge of time. We are the characters in a cosmic movie, but we are also the ones who have figured out how the projector works. This realization doesn't make the world any less real. It makes it more precious. It means that even in the vast nothingness of space, there is a hidden architecture of meaning. Every atom of stardust is a bit of information, and every life is a unique sequence in the grand holographic code. The story of the holographic principle is the story of our quest for unity. From the grand unified theory to the Voyager record, we are always looking for the one thing that connects us all. We have found it in the most unlikely place, the surface of a black hole. As you look up at the stars tonight, remember that you are not just looking out into space. You are looking at the screen. And on that screen, the story of the universe is being told with a depth and a beauty that we are only just beginning to understand. We are the hologram, and the hologram is us.